guys, welcome back to the channel. Jag here, and in today's class we're going to continue with our Math 11 content, and what we're covering today is going to be linear quadratic systems. Alright, so let's get started. Again, I'm going to pick some questions from the textbook. So what we're doing here is I have basically a quadratic equation. So let me put an example, okay? And then I also have a linear equation. I'm trying to see where the quadratic and the linear functions are actually intersecting each other, okay? And so let's try this question here. It says determine the coordinates of the points of intersection of each linear quadratic system algebraically, okay? So let's start off with a simple one. So this is y equals, okay, x squared minus 7x, okay, and plus 15. And then I have, so I can see the first function is my quadratic. The second one is going to be the linear function. So y equals 2x minus 5. Okay? So what we're going to do here is I'm going to make both of these equations equal to each other. Okay? So let's try that. So x squared minus 7x plus 15 equals to 2x minus 5. Does everyone see that? So you're making both of these equations equal to each other. Okay, move everything to one side. Okay, I'm gonna solve for the value of x here. Okay, so I'm just gonna put some arrows like this so you can see it. So x squared minus 7x, it's positive 2x here, negative 2x, okay, on the left side when you go across the equal sign. All right, I have plus 15. Also the negative 5, I see that it's negative on the right side. When you move it back to the left side, it's going to be positive 5. Okay, and then equals 0. Everyone's good so far? Okay, so we're just putting the like terms together by changing the signs and moving all the variables and the numbers to one side here. Okay, so I'm left with x squared minus 7 minus 2 minus 9x. Okay, and then 15 plus 5, which is equal to 20. Okay, equals 0. Everyone see that? I'm going to make a line here. Okay, because we do have to do a second part of this equation as well to solve it. Okay, so again, I can see that this is a trinomial, so we're going to do the sum and product here. The product is going to be this last number, so positive 20. And the sum is going to be the middle number, and in this case, it's negative 9. So I'm looking for basically two numbers. When I multiply them, it should give me positive 20. When I add them together, it should give me negative 9. Okay, so I can see my two numbers here are negative 4 and negative 5 because they do satisfy both of these equations. Okay, when you do negative 4 times negative 5, that's positive 20. Okay, make sure you're watching the signs. And when I do negative 4 plus negative 5, it's equal to negative 9. Okay, so again, because this is a simple trinomial, I don't need to show my work here. I'm just going to write out my two factors. So x minus 4 and x minus 5, which is equal to 0. Okay, everyone see that? So because we're making it equal to 0, I'm looking for the value of x here. Okay, so x minus 4, okay, equals 0, so I'll write it right here. Take the negative 4 to the other side, so x is equal to positive 4, okay? And then you do the same thing with the other factor. So I'm going to write it right here, x minus 5 equals 0. Okay, and take the negative 5 to the other side, so x is equal to positive 5. Okay, so again, some students will stop here. No, we can't stop here. These are only the x coordinates of the 2 points, okay, of intersection in this case. Okay, what I have to do is I have to take each of these points and plug it back into one of the equations, okay? Now, I always make sure I plug it into the linear equation. You can plug it into the quadratic one as well. You get the same answer, but I can see it's easier to plug it into this linear equation, okay? So I'm just going to put sub back, okay? And so let's try the first one is x equals 4. So I'm going to plug it into this equation. So 2x minus 5, okay? Everyone can see that? So I'm plugging in x equals 4. So 2 times 4 minus 5. So I have 8 minus 5, So y is equal to 3. Does everyone see that? Okay. Now I can't just plug in one of the x values here. Okay. There, see, looks like there are 2 points of intersection in this case. All right. So I'm going to plug in. Let's just make a line. I'm going to plug in my x equals 5 as well. So 2 times 5 minus 5. So this is 10 minus 5. And the y is equal to 5. Okay. Are there any questions there? So we have 2 points of intersection. Okay, I'm going to write it right here. So therefore, the first point of intersection is 4 and 3. And the second point of intersection here, okay, is going to be 5 and 5. Okay, everyone see that? Okay, and so the reason that you can actually plug in your x values into either of these equations is because both the quadratic and the linear equation or functions, they actually do intersect at 2 points here. Now say I was to graph it out and show this graphically, you will see that these are the 2 points of intersection that you do get on your graph. All right. However, again, when you do graph this out, it might not be as accurate. And that's why we are going through the algebraic method of how to solve these two functions, okay, and their point of intersection. Are there any questions there? Okay, good. So that looks good. Let's try one more example here. Okay, I'm just going to take this off. Okay, and we'll keep the line here. Okay, that way we can sub it back in, okay, at the end. All right, so, okay, let's try one where you have a complex trinomial. Okay, so the question is slightly different, okay, just in case we get this on a quiz or a test. Okay, so let's try y equals 2x squared minus 2x and plus 1. Okay, yeah, so this is the quadratic. So you can see right away that this is a complex trinomial because I have a number in front of the x squared here, okay? And let's try y equals 3x minus 5, okay? So this is my, these are my two functions here, okay? So it says determine if each quadratic function will intersect once, twice, or not at all with the given linear function, okay? So again, so let's try that first, okay? So I can show you, okay, what we're doing here. And in this case, actually, because we're looking for the number of intersecting points here, what I can do is just take this equation. I'm going to make both these equations equal to each other, okay? And what we're going to do is look for the points of intersection, okay? And what I could do is just plug this into the discriminant. Again, if you're not sure what the discriminant is, it's basically part of the quadratic equation. It's b squared minus 4ac. And when you plug in your values here, again, remember, I'm just looking for the sign of the discriminant, and that will tell me the number of solutions, okay? That will be for these two functions here, all right? Again, if you're not sure how to calculate the discriminant, make sure you do check out one of my past videos where we went through in a lot of detail how to calculate the discriminant and exactly what the results mean, all right? Okay, so let's try this example here, okay? So what we're going to do, again, is make both of these equations equal, okay? So 2x squared minus 2x plus 1 equals 3x minus 5, okay? I'm going to take everything to the left side and make sure you change the sign here. Okay, so I have 2x squared minus 2x. Okay, the 3x is positive on the right side. When you take it to the left side, it should be negative. So negative 3x plus 1. Okay, same thing with the negative 5. I'm taking it over the equal sign, so it's going to become positive 5. All right, if you take all of these variables and numbers to one side, make sure the whole equation is equal to 0. All right, so I'm left with 2x squared minus 5x plus 6 equals 0. Okay, is everyone with me so far? Okay, good. All right, so what we're going to do now, okay, I'll do it on this side here, okay? What we're going to do is just sub it into, okay, sub it into the discriminant, okay? Because this question is just saying how many actual roots or solutions there are here, okay? So let's plug it in here, okay? So b squared minus 4ac. Okay, if you're not sure, again, the values are like this, as follows, a, b, and c. the value for b is actually -5 here, okay? So make sure you are watching the signs. All right, so we're going to do -5 squared minus 4, okay? Times a, the value of a is 2. Okay, and the value of c here is +6. Okay, so it looks just like this. Okay, usually you do calculate the exact value. Okay, it really does not matter here, okay? We're not looking for the exact value, okay? So -5 squared is 25. Okay, and make sure you multiply everything. So 4 times 2 times 6, which is 48. Okay, and right away, when you subtract it, I notice that it's going to give me a negative number. I'll put the exact number down here, okay, which is -23, all right? And if you do remember, okay, from our last video, if the value for the discriminant is negative, this basically means that there are no solutions, okay? Let's put no real roots. Okay, and in this case, when there are no real roots, what that actually means is that there are no points of intersection between this quadratic function and this linear function. So they actually don't intersect each other, okay? And if you do actually graph out graphically, if I graph out the quadratic and the linear function, I'll notice that they don't intersect each other at all, okay? And in this case, the teacher cannot ask you to actually find the points of intersection because there are no points of intersection. All right, and that's all you're doing for this question. Okay, now say I did use the discriminant and the value equal to 0. What does that mean, guys? Okay, remember that means that there's only one solution or one point of intersection. All right, and in that case, the teacher can ask you to solve for the point of intersection. Okay, if the value of the discriminant is positive, again, that just means that you have two real solutions, okay? Or there will be two roots and there will be 2 points of intersection, all right? When you are solving for the points of intersection, remember in the past example, the first example we did, we were just factoring it out. If you notice that you can't find the factors, I would just put it into the quadratic formula to solve for the value of x, okay? And then make sure again that you're subbing it back into one of the original equations to solve for the value of y. Okay, and that will give you the point of intersection. All right. All right, so that looks good. And if there are no questions, that does bring this video to an end. Thank you so much for watching. Please make sure you do like, share, and subscribe to the channel. And I will see everyone in the next video. Thanks, bye.